in high school, there was a concept almost all of us know by heart. What was that? VIR. That means V equals I times R. But what that concept exactly tells us? Let us imagine a point A and a point B here, and the path connecting these 2 points. If we want a current, if we assume a charge flow from A to B, and if this path has a non-zero resistance as R, then the current is flowing through this path, can be called I, and there will be a voltage difference, the potential difference between A and B, we call it as V, that push this current through this path from A to B. This current contains an amount of charge that is accelerated by the electric field created by this voltage, the potential difference. And we can intuitively say that if R is high, then the voltage must be high because the energy that we have to push through this path should increase to let this current to flow from A to B. Therefore, we can intuitively say that V will be proportional to I. As the voltage increases, current will increase. And also, V must also be proportional to R because as R increases, voltage must increase to maintain the same current. Therefore, as we have high resistance, then it will be difficult to push through the same current. That will be difficult that same current to flow through this path. Therefore, resistance and current will be inversely proportional, or let's say 1 over I. Or inversely proportional. It's proportional to 1 over I. Therefore, from that, we can write that the voltage between 2 paths will be equal to the current flowing through that path times the resistance to it. And we call this theory, actually, we call this law as Ohm's law. The scientist George Simon Ohm, who discovered this law in this compact form, and we call this law as Ohm's law to honor his name. Here the voltage has units in volts to honor Alexandro Volta, who first discovered the DC current in a DC battery, who discovered simply the DC battery first. And the unit of the current is amperes. That is, can be ampere if it's 1 unity, and then it's amperes, it's more than unity, is to honor the Pierre Ampere, that who discovered the relationship between magnetic field and the current flow. And this is the resistance can be actually called as ohms. And the unit is omega. This is the honor of Simon Ohm, because resistance actually has the most important role in this formula. And this is amperes, A, and the volts is the unit V. Let's draw a simple circuit then to understand what is going on. We need an energy source. An energy source with a constant voltage. You can imagine that this is a battery that provides a constant voltage V. And if I connect, so you know this is across A and B. Therefore, if I assume this is A, and the point almost in this, at the same direction, like, yeah, same line, imaginary line, and connecting these two. Yeah, you don't have to draw this in a rectangular shape, but this is a convention, makes things easy. This is the same thing as the system here. What you don't see here is that this is also has a connections. This also has a connection here, and the voltage is provided by an energy source. And our resistance be shown like a zigzag between A and B, R. And our current I is flowing through the circuit. Then, when our current reaches at point A and enters the terminal of resistance, which is at the point A, it will have the highest energy that it can has, which can be represented by plus sign, but a red plus sign, to indicate that the voltage is positive and high. The energy is positive and high. And also, the negative terminal is the where our current exits this resistance, I. But the current through the circuit is always same. Don't let this to confuse you that current should be reduced because energy reduces there. No. Current is adjusted by this resistance throughout the whole circuit as I. Therefore, you will have a higher energy here, lower energy here, because there's an energy consumption at the resistance. More of that later. And this is the construction. And we have plus minus voltage here. What will be the voltage here? We know that it is V, because it is directly connected to A and B. So we can simply say it is V. I'm assuming that you don't know anything about the circuits. And I don't hesitate to emphasize everything, even if the simplest thing here. And the simplest thing that the fact that the voltage V is the voltage across the resistance directly, because it is connected directly to our energy source. We can also interchange the polarity, it doesn't matter, because this is a uniform circuit, this is a bidirectional circuit that you can, when you change the terminals, you will get the same thing. Like this, plus minus V. Oops, it should be minus plus, and then the same point A, same point B, and the same R, but in this case, plus in this direction, and the minus is here. And this is our voltage, not V, it is actually minus V. If I take actually plus minus in this direction, but if I show the terminals, if I show the polarity in this fashion, it will be plus V. Plus V, but the polarity is inverted. But it doesn't matter. And the I is flowing in this direction. Like that. Oops. I. Bear in mind that the current will always leave the positive terminal of our energy source and enters to negative terminal of our energy source. Even if this is minus V, this situation will be same. The only difference would be the current will also be minus I in that case. This is actually the minus V case, but you should again re-invert the polarities and write minus V. They represent the same thing, but these two are also same. But you should bear in mind that current will exit the positive terminal and then it re-enters the source from the negative terminal. This is actually something inverted, converted to electrons, because in that case, since electrons have negative charge, electrons will always leave minus terminal actually. But just don't let this to confuse you. you always take the current in the opposite direction to electron flow. This is a convention. And this law is called Ohm's law. And this is the most important fundamental law of all electronic circuits, where from the most complicated one to the simplest one, it is always governing law under all the relationships, even if the most complicated cases. In other words, Ohm's law is everywhere.